But you actually go in regression, linear. Let me take all these variables out so I can show you. Just like you'd be running a linear regression, you put the outcome variable in the dependent. Now the results you're going to get for this, most of them aren't going to mean anything, but really all we're concerned with here is that VIF number, which we use for multiple regression to check multicollinearity. And you can still run this because it's essentially only looking at the relationship between your independents. So let's go and put all of our independents over here in the independent list and put in two of our dummy variables. We'll go for African American and Hispanic and make Caucasian the comparison variable here. Click OK, and again we get all this linear regression results, but all we really want to look at is this VIF number for each variable: offender, gender, prior record, offense score, and those. And we want each of these, just like with multiple regression, to be below 4, which you can see all of these are below 4. So we can conclude that we meet the assumption of multicollinearity. Now we're going to ignore all the rest of the output from this linear regression because it doesn't really mean anything for what we're looking at. But all we want to look at when we run that linear regression is this VIF number, and is that below 4? And if it is, for each variable, you can conclude that you meet that assumption of no multicollinearity. Now if you have a variable above 4, just like with multiple regression, that means that that variable is potentially highly correlated with one of the other variables, and you need to kind of figure out what's going on there. You might be able to run some correlations to find what's going on more, and then you might have to take a variable out of the model. Okay, for this data set, we don't have a problem with this, so we can move on. What's the next thing we want to check? Which is actually the last thing that I'm going to have you guys check in this class. There's a few other assumptions and diagnostic tools that the book talks about, but these are the ones that I think are most important. The next thing we want to check is linearity. Just like with all the other regressions we ran, we want to check linearity. However, once again, we're checking something slightly different here. With this, we are actually testing the linearity of the logit, which is the transformed outcome variable. So that's fairly complicated, but checking it, it's not that hard to figure out, but it's actually kind of a lot of steps to check this, so let's start going through those. First, let me bring our data set back up. Now, first let me say the only thing that we need to check for linearity, we only check that with our continuous variables. So in this case, we need to check linearity of the OGS and PRS to see that they have a linear relationship with the logit of the outcome variable. Now, how do we go about doing that? It's actually a bit more complicated than the other things we've done. You actually have to go and create two new variables. And to do that, we go up to transform, compute variable. So transform, click on compute variable. Let me delete my stuff I already had in there where I was practicing. And okay, what we want to do is first we want to create a new name for these variables, and we can just say ln for log of OGS. And this is what I'm about to show you is a little bit different than what the book shows you, and I'm kind of cutting out a middleman here. So just remember that I'm doing a little bit more here with the calculations of the book, so you want to use mine and not the books for this method. So ln OGS. First thing we want to do is come click on, after we do that, type in a label, log of OGS works here. Go to arithmetic, make sure that this ln, you can go and select either up here, but we want this arithmetic under function group, and then in functions and special variables, you see this changes depending what we clicked on up here. Click on ln and then click this little up arrow to add it, and you can see there's this question mark here. Now we click on the OGS and add it over, and that's as far as the book took you, but to actually kind of cut out the middleman here, we also want to come down and click on this multiplication button and then 100. No, excuse me, that is not what I wanted to do. It is not 100, it is the log of OGS, which is what this is. This gives you the log of the OGS, and then you times that by, come and click on OGS again and add it, times it by OGS, and then click OK. That creates our new variable, we want to do the same thing for PRS, prior record score, our other continuous variables. So ln PRS, new label, log of PRS. As I said, this is a lot more complicated than this checking linearity in the others, but it's really not that bad. Okay, and here we want to delete OGS from here. Come down, click on PRS, add it there. Also delete OGS here. Click on PRS again and add it. And now we've got our log of the odds times. Essentially, this tells us it's the log of the odds of prior record score times prior record score. So, okay, now we got a variable that represents that. And it gives us a couple warnings here. For now, you guys really don't have to worry about that. Just kind of scroll down and be like, all right, it gave us a few warnings. But now, the next thing we want to do, you actually have to run a logistic regression, but this isn't going to be the one that we actually interpret anything from except for this checking of linearity. So to run a logistic, we come down to regression and then click on binary logistic. And then once again, I had some stuff already here, so let me move that out of the way. So first step here, we want to add our outcome variable into the dependent category, which our outcome variable is did judges conform. I don't know why that's showing up twice there. Okay, and then next we want to add our log of OGS variable and log of PRS. This is where I say I'm cutting out the middleman. Your book author does this where he doesn't do the times original and then you actually do it here. But we cut that out and did that in the actual formula part. And then we want to add the original variables as well. And then click OK. Spits out a whole bunch of data. The only thing we're interested in is this variables in the equation list. And we want to look at this log of OGS and log of PRS and their significant values. And we want these to not be significant. So for example, if this ln of OGS was significant, that would tell us that OGS did not have a linear relationship. Same thing with the PRS. If this was not significant here, that would tell us that PRS does not have a linear relationship with the logit of the outcome variable. But as we can see with this, we have neither of these are significant. That means that there is a linear relationship, so we can conclude that we are okay on that assumption. So again, a lot of steps in that one. Just kind of quickly review. Check the linearity of the logit. You have to first go and actually create new variables in their transform compute variable. Go down, add the ln function, then put the variable in parentheses times the variable again, and then click OK, and that creates your new variable. And then you run a logistic regression with your newly created variables, the ln variables, and the original variables. And then you want to check and go across. I was on the wrong table there, but check and go across and make sure that these are not significant. You don't need to pay attention to the significance of the original values here, just these new values here, or these new variables here. And if those are not significant, you're okay, and you can say we can go ahead and move to actually running the actual logistic regression at this point. So we have tested all our assumptions. All our assumptions have checked out. And so we are good to go with the logistic regression. All right.